Hey everyone, welcome back to Blueprint to Reality. Today, we're tackling an important topic in civil engineering: reinforced concrete versus pre-stressed concrete. Both are widely used in construction, but what sets them apart? Let's break down the key differences and help you decide which one suits your project better. Let's start with reinforced concrete. A reinforced concrete is made by embedding steel reinforcement bars, or rebar, into concrete to increase its tensile strength. Concrete is naturally strong in compression but weak in tension, and rebar helps compensate for that by resisting the tensile forces that concrete can't handle on its own. This type of concrete is commonly used in residential buildings, bridges, and roads because it's relatively simple and cost-effective to produce. The rebar is positioned before the concrete is poured, and once it cures, the steel works together with the concrete to resist loads. However, cracking can occur if the tensile stress exceeds the steel's capacity. Now, let's move on to pre-stressed concrete. A pre-stressed concrete takes the concept of reinforcement a step further. Before or during construction, steel tendons or cables are pre-tensioned or post-tensioned to put the concrete under compression. Since concrete performs best under compression, this process allows pre-stressed concrete to resist both compression and tension much more effectively than reinforced concrete. A pre-stressed concrete is often used in larger structures, like bridges, parking garages, and high-rise buildings, where minimizing cracks and deflections is crucial. By applying tension to the steel cables, the concrete remains in compression even under heavy loads, reducing the risk of cracking and allowing for longer spans and thinner slabs. So, what are the key performance differences between the two? First, crack resistance. Reinforced concrete can develop cracks under tensile loads, which can lead to structural issues over time if not properly maintained. Pre-stressed concrete, on the other hand, is designed to minimize or even eliminate cracks because of the pre-applied compression forces. Second, load-bearing capacity. Pre-stressed concrete is much stronger and can handle heavier loads and longer spans without sagging or cracking, whereas reinforced concrete is better suited for shorter spans and moderate loads. Finally, deflection. Pre-stressed concrete deflects less under load due to the tension steel, making it ideal for projects where minimizing deflection is critical. Now, let's talk about cost and complexity. A reinforced concrete is simpler and cheaper to produce, making it a go-to option for smaller projects or structures where high loads and long spans aren't as important. It's easy to work with, and the construction process is straightforward. A pre-stressed concrete, on the other hand, is more complex and requires specialized equipment and labor for tensioning the steel cables. This increases both the cost and construction time. However, the benefits of increased strength and reduced cracking make pre-stressed concrete worth the investment for larger, more demanding projects. So there you have it. Reinforced concrete is great for simpler, smaller structures, while pre-stressed concrete excels in high-load, long-span, and crack-sensitive projects. Thanks for watching. Don't forget to like, share, and subscribe for more civil engineering tips right here on Blueprint to Reality. See you in the next video. Welcome back to Blueprint to Reality, where we turn technical concepts into simple ideas. Today, we're comparing two of the most common structural systems in construction: load-bearing wall systems and frame structures. Let's break down how these systems differ and which one is right for your project. What is a load-bearing wall system? First up, the load-bearing wall system. This is one of the oldest construction methods, used in everything from ancient stone buildings to modern-day homes. In this system, walls carry the load of the building, both vertical loads, like the roof, and lateral forces, like wind or earthquakes. These walls act as the primary support, and as a result, they can't be easily modified without affecting the building's stability. One important thing to remember: load-bearing walls usually limit the size of windows and openings because the walls need to remain strong to support the structure. What is a frame structure? Next, let's talk about frame structures. Unlike load-bearing walls, frame structures use a skeleton made from either steel, reinforced concrete, or wood to support the building. In this system, the frame, columns, and beams bears the load, while the walls are mostly non-structural, serving as partitions or for insulation. This allows for much larger windows, open spaces, and flexibility in design because the walls aren't carrying any weight. Frame structures are commonly used in high-rise buildings and modern constructions where open floor plans are important. Let's go deeper into the load-bearing wall system. What are its strengths and weaknesses? On the plus side, load-bearing walls are often cost-effective for smaller buildings, especially homes, because they don't require as much steel or concrete. They also provide excellent thermal insulation, which can make a building more energy efficient. However, the downside is limited flexibility. Once the walls are in place, it's difficult to modify the layout without compromising the structure. And if you're looking to build taller than a few stories, this system becomes less practical due to the need for thicker, stronger walls. Now for the frame structure system. Why would you choose this? Frame structures offer greater design flexibility. Since the load is carried by the frame, walls can be moved or removed entirely, making it perfect for open-plan spaces. This system also supports taller buildings and allows for larger windows, which is why it's popular in high-rise and commercial structures. But there are downsides too. Frame structures can be more expensive to build due to the materials required, like steel or reinforced concrete. They can also require more specialized labor and take longer to construct. Load-bearing versus frame structures. When to choose. So, when should you choose one over the other? If you're building a low-rise structure, like a residential house or a small commercial building, the load-bearing wall system could be a cost-effective and energy-efficient option. However, if you need design flexibility, large open spaces, or if you're going for a tall building, then frame structures are the way to go. In the end, it's all about your project's needs. Load-bearing wall systems offer simplicity and cost savings, while frame structures provide flexibility and support for larger, more complex designs. Thanks for tuning in to Blueprint to Reality. Don't forget to like, subscribe, and hit the bell for more construction insights. When you think of skyscrapers, you probably picture massive steel and concrete structures piercing the sky. But here's a mind-bending question. Could we actually build a skyscraper out of wood? It sounds like something out of a fairy tale, right? Yet, with modern engineering and cutting-edge materials, timber towers are becoming more than just a possibility. They're a reality. Today, on Blueprint to Reality, we dive into the surprising science behind wooden skyscrapers. Traditional views on wood. For centuries, wood has been a go-to material for construction. It's natural, renewable, and easy to work with. But we've always associated it with small, cozy homes, not towering skyscrapers.
Why?
Because traditional wood structures have limitations. Wood burns, it's not as strong as steel, and it decays over time. So how is it possible to build something as tall and complex as a skyscraper using wood? The answer lies in a new type of wood material known as mass timber. Introducing mass timber. Mass timber is not your average 2x4. It's a revolutionary engineered wood product that involves laminating layers of wood together to create a material that's incredibly strong, durable, and surprisingly fire-resistant. One of the most popular types is cross-laminated timber, or CLT for short. Think of it as wood on steroids. What makes mass timber special is its ability to match, and sometimes even exceed, the strength of concrete and steel. Because of its strength-to-weight ratio, it can support massive loads without crumbling under pressure. Fire safety and durability. Now, you might be wondering, wait a minute, how is wood safe in a skyscraper? Doesn't it burn easily? It's a fair question, but here's where the science gets interesting. Unlike smaller pieces of wood that catch fire quickly, mass timber chars on the outside when exposed to flames, creating a protective layer that slows down the spread of fire. In many cases, mass timber buildings have proven to be just as safe, if not safer, than traditional concrete or steel structures in fire tests. And as for durability, these wooden towers are designed to last just as long as any other modern building, with minimal maintenance required. Environmental impact. One of the biggest benefits of building skyscrapers with wood is the environmental impact. Concrete and steel require a lot of energy to produce, and they release tons of carbon dioxide into the atmosphere. Wood, on the other hand, is a renewable resource that stores carbon throughout its life, making it an eco-friendly option. In fact, if we start using mass timber on a larger scale, It could drastically reduce the carbon footprint of the construction industry. We're talking about a greener future where towering cities are built from sustainable materials. Examples of timber towers. Still skeptical? Well, let's look at some real-life examples. In Norway, there's the Mjøsternet, the world's tallest timber building standing at 18 stories. And it's not alone. Projects like the Ho Tower in Vienna and Brock Commons in Vancouver are proving that wooden skyscrapers are not only possible, but are already reshaping city skylines around the world. Architects and engineers are pushing the boundaries, and some are even designing timber buildings that could reach 30 stories or higher. The potential for wooden skyscrapers is only just beginning. So, can you build a skyscraper out of wood? The answer is a resounding yes. With mass timber, we've unlocked a new frontier in construction that's not only strong and safe, but also sustainable. As urban populations grow and environmental concerns rise, timber towers could be a key part of the future. If you're as fascinated by the science of building as we are, don't forget to like, share, and subscribe to Blueprint to Reality for more mind-blowing insights into the world of construction and civil engineering. See you in the next episode. Thanks for watching.